Hi guys, in this tutorial I'm going to solve question number 3, M1 Jan 2020. Particle P is projected vertically up with a speed u from a fixed point O. Particle start from a fixed point O and projected up. The particle P is projected vertically up with a speed u. The initial velocity is u. From a fixed point O. At the instant when P reaches the greatest height h above O. So first, the greatest height when V is equal to 0. The greatest height is h. You can find equation of motion vertically up. We don't have time, so you can use V squared is equal U squared plus 2AS. The final velocity is 0. Initial velocity is given U plus 2G, negative G, and S is height. Particle P projected vertically up with speed u from a fixed point O at the instant when P reaches its greatest height above O. This part done. A second particle Q is projected. Now Q at this point. So Q, P will start to move down and Q move up. A second particle Q is projected with the speed half u. So the initial velocity here is half u. But the particle up starts from initial velocity 0 to move down. A second particle Q is projected with the speed half u vertically up from the point O. Find h in terms of u and g. This is from the first part. When the particle P reach to the maximum height, so use V is equal to 0, you can find height from this equation as a subject. 2GH is equal to U squared, so H is equal to U squared divided by 2G. This is H in terms of height. V squared equals U squared plus 2AS. The final velocity is 0, the initial velocity is U. 2, the acceleration against the gravity will be negative g. The height is h. You can find h as a subject from this equation. This is in part A. He asked to get h in terms of u and g. This part done. Part B, find in terms of u and g. Find in terms of u and g the time between the instant when Q is projected and the instant when the two particles collide. So when you projected the particle Q, let's say they collide at this point, maybe. If we try to get the displacement of P and displacement of Q have to be is equal to h. S of the particle Q and S of the particle P, their sum have to be the height, which is h. So S of Q plus S of P is equal to h. S, the displacement is ut plus half of at squared. This information about Q plus ut plus half of at squared. This information in P is equal to h. S of Q, we start with half u. The initial velocity is half u. Time is not given. Plus half acceleration is negative g times t squared. Plus particle P, initial velocity up to be 0 plus half negative g times t squared is equal to h. This part, sorry, this ng is positive, move down. Now, this part is equal to this part to be 0. So have ut is equal to h. You can find the time, which will be 2h divided by u. He asked in part B, find in terms of u and g. So you have to remove h from this equation. We already have h. Substitute in this equation to get the time in terms of g and u only. 2 divided by u, remove h, and write u squared over 2g. Simplify your answer. 2, so the answer will be u over g. This is the time in terms of u and g. Part C, find where the two particles collide. You can find S of Q only to show that where they collide, or S of B. We'll try now to get S of Q. SQ is UT plus half of AT squared equals. The initial velocity of the Q is have u, and the time found u over g plus half of acceleration is negative g, and the time squared will be u squared of g squared. Simplify, half u squared over g, simplify negative half u squared over g if you simplify. So the answer is what? Is 0. This means SQ 0, so this means they meet at O in this case. So the collision, he asked to find where the two particles collide, so they collide at O or at the initial position. That's it. Thank you.